Hello everyone, welcome to this tutorial. In this tutorial we are going to see what is an equilibrium point, an equilibrium force is. We first define it and then we will see examples in one direction, that is if it is linear, and also we will see if it have two dimensions x and y. So stay tuned, and if you have questions you may ask in the comment. Okay, let's get started. To define equilibrium of force fully, first we need to understand what is Newton's first law of force. So the first law of Newton says an object at rest stays at rest, and also an object in motion stays in motion with the same speed and with the same direction, unless there is unbalanced force. If there is unbalanced force, the object at rest can speed up or speed down or change direction. But if there is balanced force, an object will be at rest if first it was at rest, and also if it is in motion it will stay in motion. This is the definition of Newton's first law. So let's explain more. So the behavior of all objects can be described by saying that object tends to keep on doing what are they doing. If they are rest, they will be rest, and also if they are in motion, they will be at the same speed and at the same direction, unless what? Unless there is unbalanced force acted on that object. That is. So, for example, if it is at rest, it will continue at rest. If, for example, a motion is speed up at a velocity of 5 per second eastward, so they will continue in the same direction unless there is action of unbalanced force. So when all the forces that act upon the object are balanced, that is if there are multiple forces and if they act on the same object to be at equilibrium, that means to be if the object is at rest and if it is in the motion, so that it stays at the motion with the same speed and direction, so all the forces must be balanced. All the forces that act on the object must be balanced. If that is fulfilled, then the object is said to be at state of equilibrium. So when we say equilibrium, we say that all the forces acts on the object are balanced. So for example, when we say force, it is pushing or pulling. So if one pulls in the north direction, for example, in 10 Newton, there must be a balanced force that pulls 10 force in south direction, in opposite direction, to make it balance. That is the way how to make it balanced. So an object at equilibrium is either at rest and staying at rest. If it is, that means if it is at rest at a velocity of 0, then it stays at 0 since it is balanced. If it is in the motion, so it continue in the motion with the same speed and direction, because all the forces act on the object is balanced. So an object is an equilibrium if it fulfills these two conditions. So when we say forces are balanced, either an object is at rest, it means its velocity is 0, or if the object is in motion, so if it is at rest, it must stay at rest. And also if it is in motion, it must be stay in motion, but in the same speed and in the same direction. If it changes its direction, or if its speed is changed, it means there is a force applied that are unbalanced. But if they are balanced, those two either of one is fulfilled. For example, this is an object. There are two forces acting on this object. The one force, it pushes to the right at F1, and the second force pushes to the left at force 2. This shows, it is the length of this arrow shows the magnitude of the force, so they seems F1 and F2 are equal, but they have different direction. So when it pushes to this direction with magnitude of F1, it counteracts by a force of F2 in opposite direction, so their sum will be 0. So they are balanced, so this object will be at equilibrium, since the net force acting on this object is 0. When we see the second example, this arrow shows the magnitude of the force, so this magnitude is much larger than this F2 force. So since F1 is much greater than F2, the net force is not 0. It means there is unbalanced force acting on this object, so it is not at equilibrium. This object will be speed up in which direction? This one direction, because this force is much greater than that of F2. Okay, let's continue. These are in one direction. What if there is a force acting in both x and y direction? For example, this force pulls in this direction to the left, and this one, this 30 Newton, it pulls to the right. Since these forces to the right and to the left are equal, and also the force downward and upward are equal, then the net force is 0. So we say this object is at equilibrium because all forces are acting on this object are balanced. When we see this one, it also 75 to the right, to the left, upward 50 and downward 50. Even though this 50 Newton and 75 Newton are different, this 50 Newton to downward counteracted by this 50 Newton upward. So in y direction it will be 0, in x direction it also will be balanced by those two forces, so both objects are balanced. So when we say an object is an equilibrium, we say that all forces acting on this object are balanced, unless if there is unbalanced force, then this force, an object at rest may not stay at rest if there is unbalanced. But if they are balanced, so those forces are, this object will be at rest and it stays at rest, and also if it is in motion, it will be in motion at the same speed and at the same direction. So according to this Newton's first law, a force is needed to slow down or to speed up or to change direction, because if there is balanced force, we know that the object will be at rest and stays at rest, and also if it is in motion, it will be in motion at the same speed and direction. But if there is unbalanced force, it means if there is force, so it may slow down, it may speed up, or it may change direction. So the purpose of force is this one, but this law doesn't answer how much it slow down or how much it speed up or to where it change direction. It only verifies if there is unbalanced force, then it will not stay where it were. That is, so to be at equilibrium, the summation of all forces must be 0. It means force in x direction and force in y direction must be balanced. Okay, let's see some examples. For example, this box, there are two forces on this box, which are 60 Newton to the right and F Newton to the left. To be an for this object to be at equilibrium, what would be F? So since they have opposite direction, so this 60 Newton can be counteracted by the same but opposite direction force. So F should be 60 Newton to be this object at equilibrium. The same way, this object, there are four forces acting on this object. So to be this object at equilibrium, all forces acting on this object must be balanced. That means this 50 Newton must be counteracted by some forces at the same magnitude but opposite direction. So 50 Newton here must be counteracted by F1, which is 50 Newton, and also this 40 Newton must be counteracted by F2, which must be 40 Newton. In which direction? In opposite direction to this one, because since force is a vector quantity, it means it have direction. So this 50 Newton, for example, if we say this direction is positive direction, so this is 50 Newton, and what then F1 is when we say 50 Newton, so it means since it have direction, we must include minus 50. So minus 50 plus 50, it may which gives 0. That is, the summation of force is 0 in x direction, so that this must be fulfilled for also in y direction. Thus F2 must be 40 Newton. What if there is a force acted F 50 Newton at 30 degree inclined? There are four forces on this object, so there are 40 Newton here. What must be F1 and F2, so that this object must be what? At equilibrium. This needs some calculations. Okay. For first case here, F must be 60 Newton to be at equilibrium, and for the second case, 50 Newton must be counteracted by 50 Newton, and this 40 Newton must be counteracted by 40 Newton, which must have opposite direction. For the third case, we need resolving of this vector. Since this F1, which have both x and y directions, because this can be resolved to x and y. So resolving means splitting this vector in x and y directions. So first let's split this into two forces, and okay, this is a phase diagram. This one, it means 30 Newton, I mean 30 degree, and if have 50 Newton magnitude in this direction. So this must be the sum of this vector plus this vector. So this is the resultant vector of two vectors which are in y directions and in x directions. So we need to know the magnitude of Fy and Fx first. So from this right angle triangle, we can calculate Fy and Fx using Pythagoras theorem and trigonometry. So sine 30 degree means opposite, which is Fy over hypotenuse means it is F. So Fy over F means sine 30 degree. So which implies that Fy is, making crisscross, Fy would be F times 30 degree. So since we know F and we know the degree 30 degree, so 50 times sine 30 will be the magnitude of this one, and cos 30 means cos 30, its adjacent side, this one, so Fx is its adjacent side, so Fx over F. We label Fx and Fy so that this horizontal axis is, because you know it is x in x directions, we label it Fx, and since we know this one is in y axis, so we label it Fy. That is how we label. And then when we cross it, Fx will be F times cos 30 degree. So once we know these magnitudes, this one force can be split equivalently to x and y direction, two forces. So we split in x and y direction. So let's back to the questions. So this have its Fx, this force is split in x and y direction. So how many forces are acted on this object in x directions? This F1 and from this Fx, since it can be split into two, Fx and Fy. So there are, this Fx must be balanced by what? F1, but this Fx must have a direction of to the right. Let's see it. Yeah, since the force direction is this one, Fy will be this in this direction and Fx will be in this direction. So Fx have, as we see, opposite direction to that of F1. So this Fx plus this Fx must be equal to that of F1, which is, what is Fx? We know that Fx is F times cos 30 degree. So F is 50 times cos 30 degree. Cos 30 degree is root 3 over 2. So we multiply it, 25 radical 3. So it will be 43.3 Newton. In y direction, we have this 40 Newton, this F2, and plus Fy, force from this resolved vector. So in which direction we have from this resolved? Let's see it. To downward direction. So we have downward force from this one. So downward, we have two downward, F2, and from this Fy. So this Fy plus F1 must be counteracted by 40 Newton. That means this 40 Newton must be equal to F2 plus which one? Fy, which is resolved from this F vector. So F2 plus Fy must be counteracted by 40. So their sum must be equal to 40. We know I think we know Fy from this one. So Fy must, F2 must be 40 minus Fy. So 40 minus, what is Fy? 50. Fy is 50 times sine 30. Sine 30 is half. So 50 times half is 25. So 40 minus 25 Newton is, it will give 50 Newton. So if F2 is 50 Newton and if F1 is 43.3 Newton, this object will be at equilibrium. That's how we determine the object to be at equilibrium. If you have any questions regarding this one, or if you have any questions on equilibrium and Newton's law, you may ask on the comment sections. For now, I think it's enough. Goodbye.